Okay, welcome back to another Physical Sciences 3 lecture. And we have example 8 here, which is a 120 kilogram cart is travelling northwards at 16 metres per second. It then comes to rest in a distance of 18 metres. So how much heat is generated by the brakes in bringing the cart to rest? So we're just assuming all of the kinetic energy is converted into heat as it comes to rest. So we're saying that the heat is equal to half times 120 times by 16 squared. And if we put that into our calculator, we get 0.5 times 120 times by 16 squared is equal to 15,360 joules, which is equal to around about 15,000 or 15 kilojoules. That's the two significant figures. So calculate the average force exerted by the brakes. Okay, so we can remember that work is equal to change in energy, okay, which is equal to the force times the distance. Work is equal to force times distance. It's also equal to change in energy. So that means that our 15,360 joules is equal to the force times by 18 metres. 18 metres. So that means that the force is equal to 15,360 divided by 18. And we can put that into our calculator as well. We already have that in there. So if we just go divide by, it gives us the answer divided by 18. And we get 853. 853 newtons. And because it was travelling northwards originally, the brakes must be acting in a southwards direction. The frictional force would be. Okay, excellent. Okay, so the next example we have here, example 9, is a 1,000 kilogram roller coaster car at point A, 30 metres above the ground, is travelling at 2 metres per second. A short while later, it is at point C, 5 metres above the ground. Ignore friction. What is its speed at C? Okay, so with these problems here, we know that the kinetic energy plus potential energy at the start, or the initial, is equal to the EK plus EP of the final. Okay, so the initial is equal to the final. So then we can go through, let's put through in our formulas. There's a reason I don't want to put the numbers in straight away. Half. And that's because, as we can see, all these terms have mass in them, so we can just cancel them out straight away. Okay, so the mass is not important in this case. Alright, so what we need to do, then we can just put in what we know. So we know that it starts off with a speed of 2, so it's a half times 2 squared plus the gravity times height, which is 9.81 times by 30. So that's at point A. And at point C, we don't know what the speed is, so we've got half v squared plus 9.81 times by the height, which is 5. Alright, so that means that half v squared is going to be equal to, let's just go straight to our calculator now. So half times 2 squared, well, let's just say, we can just, half times 2 squared is going to be equal to 2, because it's 4 times half, which is 2, plus 9.81 times 30, and then we subtract 9.81 times 5.9. Okay, so essentially what I've done is I've subtracted both sides with this 9.81 times 5.0. So we'll put it into the calculator. We get 2 plus 9.81 times 30 minus 9.81 times 5 So it's 247.25, so we get half times v squared is equal to 247.25. So that means that v, our speed, is going to be equal to the square root of 2 times 247.25, which is equal to equal to 22.2 meters per second. Okay, part B is essentially the same. So between A and C, the car went through a loop-the-loop. Okay, so this here in the picture is a loop-the-loop, like that. And this point here, we can consider that to be point B. Okay, at point B, at the top of the loop, the car is 10 meters above the ground. Calculate the car's speed at B. Well, I'm just going to jump in because it's exactly the same problem. It's just that we've changed the 5 for a 10 essentially. So I'm just going to jump into this part there, and we're going to say that half v squared is equal to 2 plus 9.81 times 30 minus 9.81 times 10. Okay, so let's put that into the calculator. So we go, I wonder if I'm just going to copy it from down here, being quite lazy. But anyway, I'm just going to do that, and you've got 10 instead. So this time it's 198.2, which means that v equals the square root of 2 times 198.2. And I'm doing quite a fair few steps at once, being a bit quick. What happened there? Oh, that's a bit odd. Okay, seems to have fixed it. And let's just go the square root of 2 times 198.2. It's equal to 19.9. Okie doke. So please go through those steps. You might need to go through them a bit slowly or watch it a few times to understand the rearranging and things, but just take your time with it and see how you go.